Welcome. Hi, I'm Mikki, and this is Mikkipedia, where I sit down and chat to doctors, professors, athletes, practitioners, and experts in their fields related to health, nutrition, fitness, and well-being. And I'm delighted that you're here. Kia ora everyone, my name is Mikki. You are listening to Mikkipedia, and this week on the podcast I have the pleasure of bringing to you the conversation that I had with Nick Norwitz. Nick is a PhD. He has his PhD in ketogenic metabolism and neurodegenerative diseases at Oxford University, and he is currently studying towards his MD at Harvard Medical School. Nick and I jump on the podcast and we're talking about ketogenic diets, cholesterol numbers, and why we see differences in the cholesterol response between different people. So we discuss why people who have existing metabolic disorders, who might be carrying excess body fat, why on a ketogenic diet they see an improvement in their cholesterol numbers across the board, generally speaking, compared to a lean athletic individual who has no existing metabolic disorder, where we see this unexpected rise in cholesterol numbers, to like very high rises. And this is a phenomenon known as a lean mass hyperresponder, or LMHR, and Nick, along with Dave Feldman and others, have co-authored papers that have investigated this response to a ketogenic diet. We discuss in this podcast what is known about a lean mass hyperresponder, what we don't know with regards to the health risk, and also what to do about it. I'm going to link both of the papers that we discuss in today's podcast in the show notes for you to get a better understanding of the phenomenon and exactly sort of what is going on, and also, of course, details on how to find Nick. Before we jump into the podcast though, I'd just like to remind you the best way for you to support us here at Mikkipedia is to hit subscribe on your favourite podcast platform. That would be amazing. And also leave a 5-star review if you have the possibility to do that. And I'd also like to remind you that if you are a fan of Newzest, you can go to www.newzest.co.nz and get 20% off any of their products using the code Mikki20, MIKKI20. And also, if you are in Australia, you can do the same over at www.newzest.com.au and also get that 20% discount, which is a really sweet deal. Alright team, please enjoy this conversation that I have with Nick Norwitz, and if you're in a position to have a pen and paper with you, I would highly recommend it. Nick, fantastic to chat to you your Saturday evening, so I super appreciate you taking this time. But however, I did love how you said, I love geeking out on a Saturday night about things I love to talk about. Same. It's great.
This is an absolute pleasure for me. Thank you for having me on. In fact, usually on Saturday nights, I'll be having dinner with my family and I'll get scolded at the dinner table for talking shop. So this is literally what I love to do. And as an added bonus, I get to hear your lovely New Zealand accent. So just a giant win for me.
Fantastic. Nick, have you been down under, down to New Zealand?
I have not. It's on my bucket list. I really want to go. My friend went there. She went skydiving there recently and then went and saw like the glowworms in the caves. It just sounds incredible. So I have not. It's something I really want to do though. So.
Yeah, we all do that. We all skydive and see glowworms every day. It's just our daily thing.
It was on my bucket list to see the haka of the All Blacks, and I went to the Rugby World Cup in Japan, so I got to see it.
Amazing.
Which was really cool. That's just, I don't know, cool cultural thing. So
that's awesome.
One item off, but I have not yet seen the glowworms.
Yeah, well, then that's something for you to do as potentially post-physician training, right?
That'd be fun. Yep.
So, Nick, we have a range of things which I would love for us to discuss today. And I first want to talk about your own personal journey and how that sort of influenced, what you did next. But even before that, I really want to talk about some of your athletic achievements, like the fact that you had the Massachusetts record for 427 consecutive push-ups back in
Yeah,
2013. Like,
I had a lot of weird things as a kid. I was really ambitious and had
yes.
a little bit too much energy, so I devoted it to various athletic outputs, running, push-ups. That thing started. We had fitness tests in high school, and I
Yeah.
made it a goal to I'm very competitive. I'm like, I need to be best in the class across all categories, and I want to choose one to set a record in. And I just chose push-ups arbitrarily. So I trained for that in my freshman year, set the record, and then every year after that, I just became known for it, got the positive reinforcement for it, so I trained for it and just kept breaking my own record and made them like fundraisers for different charities that I liked. I think
Amazing.
senior year I was raising for polar bear conservation. I really got into that in high school. I watched the Planet Earth when I was younger, and there was that scene at the end where they're like zooming out on the polar bear on the melting Arctic, and it just like broke my heart. So part of my like side jobs, or not jobs, activities in high school was various things, including push-ups to raise money for polar bears. It was very esoteric, but
No, I love
yeah, there
it,
you go.
Nick. And as an endurance runner, I appreciated that you took out, was it the first place in the under 21 group in numerous half and full marathons. Yet not only that, were the youngest to qualify for Boston Marathon in 2014, and then completed it on crutches.
Yeah, so I really got into running, and I was pretty decent. I mean, I was
Sounds
17
it.
years old running 73-minute half marathons. My marathon time was 2:45. Unfortunately, I have a rare genetic variant. It's called LRP5A745V, long name, just a variant in the LRP5 gene that makes it so my bones don't respond well to mechanical stress. So my running career was hot, but died young. I actually developed osteoporosis, like genuine osteoporosis. My T&Z scores were negative 3.2, 3.3 at the spine after a while of running because my bones couldn't respond properly. So I had a very short running career. It was great. Unfortunately, I can't run anymore, but it was a blast, and the pinnacle was definitely getting to participate in Boston, run it or not. It was the year after the bombings, and I grew up, watching the marathon, so it was always a point of pride for my city, and getting to participate was amazing. And so, yeah, I have my moment, and now moving on to other things. My athletic prime, you're playing me up, is definitely past me, but I'm okay with that.
That is,
On to other things.
On to other things. Because how old are you, Nick?
I'm 26.
26. Yeah.
Yeah.
No, I feel like you've got a lot of sort of strings to your bow for someone who is 26, like quite a bit younger than probably what on paper you would expect, given what you've achieved and where you're up to. But you mentioned your osteoporosis, and as I understand it, was partly your health journey that maybe made you interested in what you might be doing professionally, or it might have nothing to do with it. But regardless, can we chat about that? Can you talk us through the osteoporosis sort of diagnosis and then sort of what led on from that?
Yeah, for sure. I mean, that particular diagnosis I'll actually table. Genetics
Cool.
are complicated. Treatment, likewise. I don't want to waste people's time. What ended up happening next that was actually more serious for my quality of life was I started to develop ulcerative colitis, which is an inflammatory bowel disease. I'm sorry to get graphic for people, but it's you have bloody diarrhea, urgency, lots of pain after eating. It makes engaging in social activities, participating in academics, extracurriculars extremely difficult. So I went from being someone who had no food restrictions, could eat anything, was an introvert, but at the same time pretty outgoing, to really just trying to cope with life and cover up the daily pain and anxiety that was defining my existence. So this was happening. I was developing these symptoms at the end of college. I went to Dartmouth College in New Hampshire in the United States. And so I was finishing up school, going on to the next thing, which for me was studying to do my PhD at Oxford. And in that transition, I was just really confused about what to do. I was trying a lot of the conventional things, and they just weren't working. And I was losing a bit of hope, but I didn't know what else to do but to go through the checklist of like, this is standard of care. Also, I have so much respect. I was going to say have, but I have so much respect for my physicians. They're so brilliant, and I really had a great connection with a lot of them that I trusted them. And I trusted that they were doing the best thing by me given the evidence, which they knew better than me. So I kind of, just followed what I was told to do. But it wasn't really working that well for me. And got to a point where I was really in desperate straits. I just moved to the UK. It was several months after starting my thesis studies. Had a particularly bad flare for whatever reason, and ended up in the ICU. The NHS actually placed me in palliative care for a little while. I think it's just because I ran out of beds. But for me, that was still a very scary experience and wake-up call, being in a room of people who were literally dying. I was the youngest person there by like 60 years. I was emaciated. My heart rate had dropped down probably from malnourishment into the 20s, and I felt horrible. And it, contrasting to what we just talked about, me running sub 3-hour marathons, doing 400 push-ups in a set, it was a matter of like, I didn't have the energy to walk down the hall and go to the bathroom. That was exercise for me. And so kind of reflecting on, wow, I've gone downhill quickly, and having the juxtaposition between where my health was and the possibilities that were ahead of me if I could deal with that. I'd gotten a place at Harvard Medical School. I was doing a PhD at Oxford, like all the potential in the world, right? And yet I'm like, I can't stand existing right now. I don't know what to do. I had a lot of hope, lost a lot of hope, and I just started experimenting with things out of no expectation but desperation. And one of the things I tried after trying a bunch of different diets was a ketogenic diet. And for me, it worked remarkably well, to the point that the bleeding and the urgency and the weight loss stopped.
Yeah.
And started to reverse, and I started to get energy back. My brain fog cleared up. I just started to feel a lot better. I didn't really care about the mechanism. I thought it was kind of a fluke, a one-off. I still thought it was a weird intervention. I didn't become a convert per se in that moment. But as I felt better and was benefiting from this on the side of my studies, I really got interested in metabolic health and nutrition, obviously. I did a weird intervention and I had this really weird response. Being someone who's curious, I wanted to know more. And then as I started to dig into the basic science literature around it, while digging also into, or should I say, engaging in the community around low-carb and ketogenic diets, I started to observe this interesting motif, this pattern, whereby people who had lots of different metabolic diseases, autoimmune diseases, inflammatory diseases, had a similar experience to me, where they got desperate, tried something, and it worked really well. That's something, of course, being a ketogenic or carbohydrate-restricted diet. I'm like, that's weird, because in terms of clinical trials, there's not much. There's no clinical trial saying a ketogenic diet helps for ulcerative colitis, but yet I could pick out easily a dozen people who had done it and who had benefited. Same for rheumatoid arthritis or even lupus. Like, I was seeing it all over the place, especially diabetes and obesity, and I'm like, well, this isn't standard of care. There aren't clinical trials on it, but I can't ignore the fact that it's helping a ton of people.
Yeah.
Just like me, like really bringing them back to health and life. And so I became very interested in it. And that has really dictated the direction of my career. Now I believe that there is a lot to this, and I want to be part of introducing it as an option to the next generation of doctors, my peers, and also pursuing the research around this so that we can actually make this standard of care, because right now there isn't the evidence base to allow that to be possible. But I think that the biological plausibility, the basic science, and just the volume of anecdotes suggests that if we can actually do those trials, they'll be positive, and then these sort of interventions can be provided to patients as options by their doctors so they don't have to suffer to the point of desperation or, never finding a solution in the first place. So that is really dictated. I always knew I wanted to be a doctor, but I never thought I'd be interested in nutrition. Like everybody else, when I started my journey, I'm like, I know what healthy is. it's my plate, it's food pyramid, it's balanced eating, it's calories in, calories out. And now I couldn't have a different perspective.
Yeah, it's so interesting, isn't it? Nick, a couple of questions on that. You're at that stage where you embarked on the ketogenic diet. How long did it take you to see some resolution of your symptoms? Was it immediate? Did it take time? And I know this is
Within a
your
week.
personal experience. Wow.
Within a week.
That's amazing.
And I know that because I started it while I was on holiday in the US. And I had a pretty immediate response, but I started it 1 week before I had to go back to Oxford. And I asked my gastroenterologist if we could get a calprotectin check. Calprotectin is a marker of inflammation in the stool. And his response was, I don't expect it to have changed. Even if you were having a decrease in inflammation, it would just take a little bit of a lag time. Although maybe we'll see something, so let's just check it anyway, because it's hard to get in the UK. So I knew it had to be within that week, and it dropped to its lowest levels ever. It had dropped 8-fold in that week. And I was feeling better at the same time. And then more or less it stayed consistently down since then. The only times it's gone up is during acute infections. Like I had a Campylobacter jejuni infection from eating undercooked liver, which was just me being stupid because I like things rare. And then, just during acute exposures. I had a mold exposure, stuff like that. But otherwise, it's been pretty stable, so I haven't had to worry about colitis flares. Which is nice.
Yeah, and your gastroenterologist at the time and sort of any sort of subsequent health professionals who you work with, what has been their response to your experience? Really open, really like, oh, that's a fluke? Like,
I have a really good relationship with all the health professionals that I continue to engage in, and I think they respect my perspective and I respect theirs. It's just kind of the thing that is... It's a thing for Nick. This is what Nick does. We're not going to push back because it seems to be working for him. And whether or not it's a fluke is not relevant because this is what I'm going to do. And I'm forward about that. And then we can discuss the complications that arise because of it, because, there are what many people could consider downsides in terms of metabolic changes in someone like me when I adopt a particular lifestyle. That's a current area of interest for me, lipids in lean people who go on ketogenic diets. It seems like a niche thing, but it's actually quite interesting. So again, there are what could be considered points of conflict that arise, but as long as I approach my doctors with respect, they tend to treat me with respect, and we can just handle these on a individual patient basis, me being that individual patient, and discuss, okay, here's the evidence, here are our options, let's weigh the pros and cons, and in the end, the patient, me, has a prerogative to make whatever decision they want, and good physicians will almost always respect that.
Yeah, no, I really like that.
That's where we are. I really love my physicians. I couldn't say more positive things about them.
That's awesome. And Nick, with regards to your keto diet, because I'd love to chat about the potential sort of side effects that you're experiencing, which has sort of led to what you're currently interested in with regards to cholesterol levels. Is it a dairy-free diet, your keto diet?
No, it used to be dairy-free. When I first went keto, my keto's changed a lot in the way it looks. When I first went keto, what it looked like is almost no red meat, very little dairy. If it's dairy, just a little bit of cheese, maybe like 30 grams a day tops, and lots of avocado, monounsaturated fat, polyunsaturated fat, fish, just because that's, at the time, what I thought was the best of both worlds, a kind of Mediterranean style mixed with keto. Over the time, it's evolved. I've been fully carnivore. I've been more plant-based. I just like to tweak things and experiment. Right now, what it looks like is a decent amount of plants based largely on fermented food. I've really gotten into fermented food. It's my new little niche based on some paper I read in Cell and some of the benefits I think there might be for fermented food. So my plant base would include things like kimchi and natto, black garlic, but also kefir, things that are probiotic like blue cheese. And then my main proteins are fatty fish, salmon, sardines, but also, sometimes meat stuff. It's just what I like. I eat a lot of olives, ton of olive oil, again, that's just what I like. There's lots of different ways to slice it. I don't think there is any best way or worst way. I mostly go with what I have an appetite for and what I'm doing for experimentation purposes.
Yeah.
Because I'm always experimenting on myself. But yeah, in terms of the effects for me, and this might be prematurely transitioning into what we will talk about later, but one of the things we've discovered, and when I say me, I mean myself, Dave Feldman, and some of our colleagues at Harvard and elsewhere, is that carbohydrate restriction itself can really spike the LDL, quote, bad cholesterol. So, when you get a lipid panel, there's the LDL cholesterol. It's what your doctor's primarily looking at to assess your heart risk, determine whether or not to put you on a statin. For most doctors, not all. The literature around that is very complicated. And what we're observing is that this really funny pattern. And if you're not super nerdy like us, you might miss why I think this is so weird. But where the people that are seeing these spikes in the, quote, bad cholesterol are generally the metabolically healthy, the insulin sensitive, and lean people. So you'd think, okay, this is an unhealthy response. Maybe you see it in the unhealthy people, the people with diabetes, the people with obesity. But in fact, those people, people that have excess fat, people that have diabetes, metabolic syndrome, generally when they go low carb, their cardiovascular risk markers improve across the board. Their HDL improves, their triglycerides improves, their LDL improves, their lipoprotein is IR improves, their LP to the light can even improve. And then it's specifically in the leaner people who are metabolically healthy, lower triglycerides, higher HDL, you see this massive spike in LDL that can be independent of saturated fat intake. So, you think, okay, somebody goes low carb, they're eating a ton of butter, cream, red meat, that's what's causing the LDL to rise. Well, no, that's not the case. At least I can tell you that's not the case with me, because when I went low carb, it was like lots of fiber and plants, avocado, olives, almost no cheese or red meat. And yet my LDL over tripled.
Wow.
In the initial 6 months, it went from like around the 90s to well over 300, which is like, whoa, what's going on there? And it's fluctuated. It's gone up well above 500, which is, again, like just setting aside the risk factor, because that would give most doctors a heart attack to even look at. That's really weird and interesting, because it's like those are levels so high that prior to observing it in what we call now, quote, lean mass hyper-responders, this would be a level you think, okay, this can only present in someone with homozygous familial hypercholesterolemia, which is a 1 in 1 million disease.
Yeah.
But based on the genetics that we've looked at, there doesn't appear to be a clear genetic link. People aren't hyper-consuming saturated fat, and even if they were, they probably couldn't spike it to those levels. And it varies with body mass and can be reversed easily with carb reintroduction. So if you just take a person, and we did this in a case series, and they have LDL levels 300, 400, 500, this one guy, LDL 665, we say, introduce 50 to 100 grams of carbs. We just want to top your liver up with glycogen and shift your basis for energy metabolism a little bit away from fat back to carbohydrates. LDL dropped in this guy, for example, by 480.
Wow.
So basically what I'm saying is, like, we took this guy, gave him about a sweet potato's worth of carbs per day, and the LDL drop effect was that of like 10 statins on top of each other, which, I'm going to set aside the risk thing. That's a very hairy topic. And I'm just going to say, intellectually, scientifically, that is like blow your mind. That is so cool. And I just am really into, what's going on with energy metabolism and how we say these lipid levels change. So that's kind of where my extracurricular interests are right now.
Yeah, no, and I would love to discuss this next. So if I just sort of step back a little bit, you mentioned a term called familial hypercholesterolemia, which is that genetic condition whereby your cholesterol is just like ridiculously high, like tenfold or whatever higher than what you might normally see. Now, the reason why I want to talk about that is because a lot of people think that because their parents had high cholesterol, that genetically they're going to have high cholesterol, but their numbers in their head might be, and I don't know if you know the conversion, but here in New Zealand we use, the labs often use 5 millimole as a high cutoff, and theirs might be 6 or 7, which to my mind isn't high at all. But these aren't numbers that you're talking about. You're with people who have familial hypercholesterolemia, they're so much higher. And then the numbers you're talking about for the people who are lean mass hyper responders are again in that realm of extremely high, aren't they?
Yeah. I'm accustomed to the American units of milligrams per deciliter, but the conversion's like times 38.6. So we could do it.
Yeah.
But yeah, no, the levels we're talking about, let me just if we're saying someone with high cholesterol, you're saying 5, right? Is that like the cutoff for high? That would be the equivalent of 190 about, which is the cutoff for, like, if you're above that, you might have familial hypercholesterolemia. What I'm talking about in homozygous FH, so heterozygous having one copy of a messed up gene will give you levels of, like, I don't know, maybe 7.5, so 290, 7.5 millimoles. And then homozygous FH, you might have levels of like 15 or even 20 millimoles, so like 500, 600, 700. We're seeing those levels in lean mass hyperresponders that high.
Yeah.
So it's like, when you're worrying about 5 millimoles, I'm talking about 15.
Yeah, cool.
And so to convert, like, my highest has been in millimoles like 14, which is astonishingly high considering at baseline my levels are 2.5. Like, I don't have it. If it was a genetic cause, I would have had it my whole life.
Yeah.
Which is evidently not the case. This was a transition. And I've tried cholesterol restriction. In fact, the highest my LDL ever was, is going to be funny, is when I intentionally restricted cholesterol and saturated fat. What happened during that period is I dropped more weight, and per our lipid energy model, being leaner will actually increase your LDL. So I'm like, all right, maybe I'm hyper-absorbing cholesterol, so let me get rid of all the liver and the shellfish and the egg yolks, and my LDL went up because I just cut back fat and my weight dropped, which is, again, really fascinating. What's going on here? I mean, the core of our model, we can dig into the nitty-gritty if you want, but basically is that the high LDL results from a dependence on fat as fuel, more so in very lean people when they're very carbohydrate restricted, and the fat cells release fatty acids that go to the liver, get repackaged into triglycerides, which is the storage form of fat, then sent on board these VLDL particles, which you can think of like boats carrying fat fuel. They get shipped out from the liver to deliver, replenished fat in the adipocytes, the fat cells, and then supply energy to the muscle cells, the cardiomyocytes, the heart muscles, the skeletal muscle cells. And so you end up having this cycle, and in the process of the delivery of these VLDLs, which are carrying lots of fat, the fat gets sucked out. The VLDLs then turn into LDL particles, which reside in the blood for longer. So as a result of the shuttling out of the VLDL and their really increased turnover, you end up with more LDL. And as a response, or as a coupling with this, when these VLDL, these precursors to the LDL that people are looking at on a standard lab test, as VLDL are turning into LDL, the surface remnants. So if you imagine the VLDL is a big, big sphere, right? Yeah. In the center is the triglycerides, the fatty fuel. Those get sent into the adipocytes and the muscle cells, so they get sucked out. They actually drop. So much so that your triglycerides, even though you're eating a high-fat diet and you're shipping out a lot of fat, are very, very low. Triglycerides of like 40 to 50 milligrams per deciliter. The LDL is astronomically high, but the HDL is also very high because as you're shrinking this big sphere, you're pulling out its center, you're pulling out its fat fuel stores. The surface has to remodel, right? You take a sphere, you suck out the center, the surface gets smaller. And the surface is where the cholesterol is, the free cholesterol. And so that breaks off as these surface remnants containing cholesterol. And HDL particles, the so-called good cholesterol, are the particles that contain the cholesterol fraction, that is the good cholesterol fraction. I know it gets kind of wordy, but they're very good at sucking up those surface remnants. That's part of their job. So to simplify all this down, basically the basis of our model to explain what's going on in lean people who go low carb, who have responses like me and like Dave Feldman, who some of your listeners may know, The basis of it is that there's an increased dependence on fat as fuel. The body is responding to that need, and the metabolic result is this triad phenotype of very high LDL along with very high HDL and low triglycerides. And that's what a lean mass hyperresponder is a metabolic phenotype of very high LDL, very high HDL, and low triglycerides, which just so happens to, if you're focusing on the LDL, mimic familial hypercholesterolemia, which is an extremely provocative finding because this is a disease, FH, that kills. It is devastating. I mean, the original research was talking about 8-year-olds having heart attacks, xanthomas popping up over their bodies. It's really horrible. But it's caused by a breakage, a dysfunction in lipid metabolism, which one could argue is distinct from a metabolic response, which we think we're seeing in lean mass hyperresponders. Now, that doesn't mean that lean mass hyperresponders aren't at massively increased risk. And one of my major side duties is teaching LMHR, lean mass hyperresponders, how to reduce their LDL if that's an option for them. It's not an option for all patients because sometimes it's a rock and a hard place, right? Imagine you have a kid, and we have these, with epilepsy, who's lean and is a lean mass hyperresponder. And it's like, okay, on a ketogenic diet, I don't have seizures. So if I introduce carbs, I'll have lower LDL, but then I'll have more seizures. So how do you balance those factors? Like, that's a hard thing. Yeah. For any old person that's just using it for, getting lean, getting ripped, maybe athletic performance, I'm like, dude, just eat a banana, like be conservative until we have more data. I'd rather just have a banana and have LDL of 90 rather than 500. I think that's a conservative approach. But not everybody's has the luxury of deciding that. And plus, scientifically, this is just blow your mind fascinating. I think. And so I have fun studying that.
Yeah, and a couple of points which I picked up from your paper. One was that the actual average carbohydrate intake was actually very low, wasn't it? So 37 grams. Was that total carbohydrate? Is that how you
I think it was 27 in the cohort study was average, and it was net carbohydrates. That was based on self-reporting, but basically, people were on ketogenic diets. The definition of low carb in the study was less than 130, but this is something we're seeing in people whose carbs are low enough to deplete the glycogen in their liver, put them in ketosis. Yeah. So if you have just a little bit more carbs, like, you add a sweet potato per day, and you drop out of ketosis, your liver glycogen goes up, you can still be pretty low carb, but generally your LDL will be a lot lower if you're a hyperresponder. Not everybody is. And if you have diabetes or obesity or overweight, then you're probably less likely to have this response. If anything, your LDL might go down. We do see that. So it's that's an important distinction because I think, it's the boogeyman, the LDL. And so there's a lot of doctors who are kind of afraid of putting their patients with diabetes or obesity on a ketogenic diet because your LDL will go up. And what the literature is showing is actually no, that's not the case. Your LDL might go down. Your LDL profile on NMR will almost certainly improve. Your cardiovascular risk is going to improve for major use cases for ketogenic diets, diabetes, and obesity. So, that population of patients probably, and their doctors, should be reassured, if anything. It's the people like me who are using it for other cases and who tend to be kind of lean that we see this weird response.
Nick, is the response that we see with the ketogenic diet, is it similar to or more pronounced than what you see if people are fasting? And I ask that because I have a number of clients who enjoy intermittent fasting and then they get their LDL, checked or their cholesterol checked and it's a lot higher. And so is the mechanism the same there? Do you know?
Yeah, it's well, I don't know because a lot of this is in the realm of speculation, but a lot of the literature we actually base the lipid energy model on, the formal paper, which maybe you can link in the show notes so people can read it. Also, Dave did an amazing 5-minute video abstract on it, which you should also link. He's great with graphics, so that'll break it down for people. But basically, it's the same idea, right? What's the job of intermittent fasting or a ketogenic diet? It's to reduce insulin, put you in a fat-burning state. So I think that's analogous. Now, if you're doing intermittent fasting, but you're eating more carbs, you're still going to kind of be repleting your glycogen stores and are not likely to see very high responses. So if you do like an 8-hour feeding window and you're eating 100 grams of carbs per day, I really don't think your LDL is going to go up that much. In terms of order of magnitude, like maybe it'll spike a little bit, but you're not going to go to levels of 500. Or I think it'd be very unlikely for you to get that high. Now, if you're combining intermittent fasting with a ketogenic diet, then those things potentially could compound. But I think the carbohydrate level is going to have a much stronger influence than intermittent fasting.
Yeah. What role, if any, does insulin play in this, Nick? So obviously the depletion of glycogen is a key sort of factor. Does it, what's going on there? Anything?
I think if you asked anybody what role does insulin play, and they're in metabolic health and nutrition, you'll never get the answer no. It always plays a role, right? So yeah, I think one of the reasons one of the things that maybe kicks off the lipid energy model cycle is a reduction in insulin to allow for fat to be liberated from fat stores. So, you think about insulin as the lock on the adipocytes, right? And so if you spike your insulin with carbs, you're going to be preventing free fatty acid release, which is necessary for the whole cycle of the lipid energy model to start. Now, I think there's several hormones that are in play, including leptin. But I think insulin's at the core of it, just like it's at the core of carbohydrate insulin model. I don't know. All models in low carb, we're going to come back to insulin in some respect. It's a very interesting hormone. But the short answer is, I think that low insulin is necessary for this to manifest. Okay,
interesting. And I have seen some data, and I don't know if it's been replicated. I don't know how set this is or how well known it is, but I believe that Jeff Volek talked about athletes, I think the faster athletes, so the ultra endurance athletes who were, who have been ketogenic for, at least 6 months. But they talked about the possibility of, as you are further fat adapted, that you can begin to store glycogen and obviously you spare glycogen. So in a ketogenic state, you aren't going to have that same level of glycogen depletion that you might be if you're just new coming into it. So is there a time effect here, Nick? Do we even know this?
You're asking dangerous questions, not because of risk, but because you're risking me going off on real nerd tangents. But I'll do that.
Awesome.
First of all, yes. Actually, some of the some of the control trials, that wasn't a randomized control trial, that was a cross-sectional cohort study, but that we based the lipid energy model on, or that we cite, include the work done by Finney and Volek on comparing ultra-endurance runners eating low-carb versus high-carb diets. What they showed is LDL levels in the low-carb athletes were twice as high as in the high-carb athletes. Interestingly, and I did a presentation for the School of Public Health on lean mass hyperresponders. If you look at the levels in their ultra-endurance runner cohort, and then you line up the cutoffs for lean mass hyperresponders to the profile, they line up pretty damn close. Okay, which is funny. Now, their runners were eating, I think, 10% carbs, like 80 plus grams, 82-ish, I think, grams of carbs per day. So higher to the point that, like, I wouldn't expect them to be fully lean mass hyperresponder, but they're, like, trending towards it. I bet you if you took them and put them on, like, 20-gram carb diets, you would see them manifest that. But they're pretty active, so they'd be manifesting a lot of the profile. Anyway, we do see this lean mass hyperresponder-like phenotype in that population. The one other study that was interesting was there was a randomized controlled trial of very lean women in which all 17, when they went low carb, saw spikes in LDL. And the reason this is interesting is because those two studies, the Buren 2021 paper, the randomized controlled trial I just mentioned, and the Finney and Volek study, stand out among the literature in terms of studies looking at low carb diets where LDL is higher. When you go low carb. A lot of the other studies say, you go low carb, LDL doesn't change much, or if it changes a tiny bit. Those are the only two where LDL spikes dramatically, and they're also the only two that I can think of that stand out for having lean participants. In fact, and this is just a complete Easter egg fun fact, the average BMI in our lean mass hyperresponder study cohort, the Finney and Volek ultramarathon study, the Buren study, the mean BMIs in all three groups are 22, which is just funny. It's just a coincidence. But anyway, that is an aside. So that's one thing. Now, your other question was a time effect. This gets complicated because you're right. Over time, what you'll see is first, as you increase the ability to burn fat, you're burning more fat at higher intensities, so you have to pull on glycogen less, right?
Yes.
So your glycogen stores will stay higher longer. So it might start where, okay, you have a glycogen tank of 100%, right? And you compare low carb and high carb athletes, they're both at 100%. But the low carb athlete's going to deplete that glycogen, so they're going to be, say, at 20%. Over time, that'll come up a little bit. Let's say it's at 50% at baseline before a workout, as compared to 100% in the high carb athlete. But then when they work out, there'll be less pull in the low carb athlete, so maybe they go from 50% to 30%, as compared to the high carb athlete who pulls from 100% to 30% because they have to rely on carbs more. So, and then even over more time, what you might see is the glycogen stores, at least in the muscle, I'm not sure about the liver, coming back closer to baseline.
Yeah.
And I think that time frame's more like over a year, more like 20 months, I think, based on some of their research. Nevertheless, you're still going to have a slower pull on glycogen, such that, in theory, and I'm not sure if this has been demonstrated, but, in a fully fat-adapted athlete, if you look at muscle glycogen stores, post-workout in a low-carb athlete versus a high-carb athlete, the low-carb athlete might have higher stores because they started at similar levels and they pulled on the glycogen stores less because they're better at burning fat.
Yeah.
This gets hairy because skeletal muscle stores and liver stores are different, and because the trigger for the lipid energy model for the drop in, actually it's leptin.
Yes.
Might have to do the signal with not the absolute level of hepatic glycogen stores, which again might not relate to skeletal stores, but the rate of glycogenolysis, how fast the glycogen is broken down. I'm basing that, I'm extrapolating from a 2018 Cell paper by Perry et al., where they actually showed that it's the rate of glycogenolysis, how fast you're breaking down glycogen, that accounts for a drop in leptin that allows for free fatty acids to be liberated. Sorry for listeners if this is getting really nerdy, but basically the idea is as you lose glycogen from your liver, you're going to kind of slow down the rate at which you can liberate glycogen. That's going to be the thing that signals, okay, we need to liberate more fatty acids. The hormone that's communicating that signal is leptin, and leptin's going to drop.
Yeah.
Which is confusing for many reasons because leptin's thought of as a long-term hormone, but then you can have short-term effects. And then you extrapolate this to the human research, and I'm saying, okay, you can have higher liver glycogen stores, but then lower glycogenolysis. You can see how this gets really complicated really quickly. I'm communicating this to you, Mikki, because I'm figuring maybe you can follow me, and for the 1 or 2% of people who are maybe following along. But just to zoom out for a second, to bring it back to Earth, there are hormonal changes that occur when you're lean and fat adapted and on a low carb diet that allow for greater dependence on fat as fuel. And that may manifest in this really bizarre phenotype profile we're seeing in lean people who go low carb, where they end up with these astronomically high LDL cholesterol levels, even separate from the common factors that we think drive high cholesterol, like genetics, as far as we know, and saturated fat. So it's really interesting and something that's not really well understood, including by physicians and people just in social media who jump to conclusions about what might be the driving causes, which can be dangerous from a clinical perspective, but also just shortchanges the complexity of the research, which, if we... this is one of those things that, it's the exception that might make the rule. Pursuing this could really help us understand a lot more about the markers that we generally use to assess risk and what's really going on with them, what they're really reflecting in different metabolic states. I think there's just a lot of potential for better understanding of lipidology, human lipid metabolism, by investigating this really niche group, these lean mass hyperresponders. And just as a little pat on the back aside, the responses we've had to our papers have been great, especially within academia. There's a lot of hand waving in social media, but it's been a great privilege to be in the circles I'm in and be able to take our papers to professors at Massachusetts General Hospital and Harvard and get their input. Really respected cardiologists and lipidologists, and generally the response I get is the best response I could get, which is, "Huh, that's really weird. We need more research on that."
Yeah.
Which is all that one can claim right now. This is scary from a clinical perspective, absolutely, but it's freaking fascinating.
Yeah. Do you know, it's interesting, Nick, that you as a sort of in training doctor, that you, for some of the people, are encouraging them to lower their LDL. And I think this just really speaks to that, under the idea that we actually don't know the risk. And, you know, cholesterol has long been held up as the only thing that we need to worry about for cardiovascular disease. It's the only marker that some doctors seem to continue to look at and really sort of worry about, without thinking about inflammation, without thinking about lifestyle or, you know, visceral fat or anything like that. I have this person on social who has, we've sort of interacted for a number of years, and he always pushes back at me when I talk about cholesterol and the potential, you know, how might you reduce it? Because there are a number of dietary things that you can do, like psyllium husk is, you know, like a very good one. Anyway, and he always pushes back and says, my LDL's 11 and I'm not at all worried about this. And I'm, you know, and I think that's really good. But I think as a clinician, I feel a little bit nervous to just put it out there and go, yeah, you're sweet if you're low carb. So it's, well, what would it take for us to know, I suppose, the risk associated here? Is it just randomized controlled trials in a number of different populations? Is this what we need?
First of all, in terms of the data we need, I mean, ideally, randomized controlled trials that are long-term so we could actually look at risk outcomes. The thing is, we will never see those, because think about what that would require to do a randomized trial. So it's not self-selecting. You're saying, I'm going to take you and you get to go on this diet and I'm going to control your diet for 10 years to see what the outcomes are. And we're going to fund this. We're going to do a feeding trial. So it's going to be several $1 billion and we're expecting you to adhere to it. And, you know, so we can power for outcomes. Like, you can't do some of these trials. You just can't do them.
Yeah.
And, you know, getting the ethical clearance for that wouldn't be allowed anyway. So we have to deal with what we have, which in this case probably isn't a randomized trial, because people aren't going to be randomized. They're going to be self-selecting for these diets. So the next best thing is to follow people who are choosing to adopt this lifestyle, and choosing to go against standard of care of their own volition and not lower their LDL from what you said, 11, which would be what, like in milligrams per deciliter to make this, that's 425. Like, that's almost homozygous FH levels. That's scary levels. Your doctor is going to be kind of pissed with you. But the patient has the right to choose that, and there are a lot of people who are. So we can still follow them and see what happens. And, you know, could we wait 10 years to see if they have more heart attacks? Yeah, we could, but then we'll have the data in, you know, 2032, which we might, but I also don't want to just wait that long. So the next best thing to do is look for functional progression of plaque via advanced scans, coronary CT angiography, and we're doing that right now. Dave Feldman's lean mass hyperresponder study coming out of the Lundquist Institute is a prospective trial tracking the plaque progression, and right now 100 lean mass hyperresponders. It's recruiting, so if you're in the United States and you're interested, find a way to reach out to me or reach out to Dave. I can put you in contact with him, and maybe we can get you recruited. There are certain inclusion criteria, like you have to have been low carb for at least 2 years, and other things. But it is still recruiting, so in a little bit of time, we'll have some preliminary data to see if people are progressing really quickly or more slowly than we'd expect.
Yeah.
So those are the kind of the data that are going to inform what's to come and risk. That said, I also want to comment on the right now, because like you just described, there are varying opinions on the risk. You have people saying my LDL is 11 or 425 milligrams per deciliter, and I'm not worried because LDL does not cause heart disease. And there are other people saying LDL is a very important thing. You should always lower LDL. You should always lower ApoB if you want to get really technical.
Yeah.
And ApoB's high, you lower it, no questions asked. Now, I think both of those statements are oversimplification. And it's unfortunate that discussion in social media gets very cultish and defensive on either side. And people kind of need to either choose a group, or if they don't choose a group, you generally get placed into a group.
Yeah.
So the conversation always gets oversimplified if you're engaging with it on something like Twitter, which is where I'm kind of active. So I literally have people in the low carb community saying, "How dare you help people lower their LDL?" And then these are the same, like, there's an irony. I've had people say I'm a shill for statin industry, and I'm walking around with LDLs of 400, 500. I'm like, yeah, that makes sense. There's an irony. Of course, other people saying I'm encouraging high LDL because I have high LDL. And what it comes down to is an individual discussion with a patient and weighing pros and cons. And what I would say right now is, because we don't have the data, and the overall balance of the data would probably lean towards high ApoB contributing to increased risk. Now, that increased risk is going to be modified by other risk variables, and if you have no other risk factors, there might be an increased risk, but the absolute increase might be low. We don't know that. Nevertheless, all things being equal, like I said earlier, let's say the spectrum of possibilities for having super high ApoB are, and I'm going to be, make extreme claims here, but maybe there's no increased risk, or maybe there's a giant increased risk, or it's any possibility in between, right? Given that we don't know, if you don't have any health indications for being low carb, why not just have a sweet potato and lower your LDL?
Yeah.
Like, time it with a workout and improve your workout performance. Like, it's not a difficult thing. It's not like it's not a big imposition on your quality of life, at least I wouldn't think. Now, it gets more complicated when you have people with competing health issues, and then you have to have a discussion, not denying that LDL might have a contribution, but saying, we don't know that it does exactly, and we don't know how much in this context, and you have this other competing health issue. So let's have a discussion about what our options are in terms of lifestyle and medications, what makes sense to you, what you're comfortable with, and then we'll kind of reassess as data come out. And I always encourage people to get functional markers of progression. So there's a very big difference between a 26-year-old with completely clear arteries on CT angiography, because you have buffer room to wait for literature, versus someone who has, they're in their 60s, 70s, they have plaque that are really occluding their arteries already, pre-existing disease. You have no buffer room. So you want to be a lot more conservative.
Yeah, for sure.
So it becomes a very nuanced and individual discussion. Unfortunately, you can't give medical advice, or you shouldn't, on social media. This should be a discussion with doctors, and I don't think most doctors are aware of the research that's going on around lean mass hyperresponders. So a lot of people find themselves confused and up shit's creek, and then looking for support from people who aren't really qualified to give their 2 cents on social media, and most conversations lack nuance. Hopefully that'll change over time. But right now, I just really encourage people to try to get out of the echo chamber and just listen to people on other sides of the fence really open-mindedly, because I do see how this pattern develops of people saying LDL doesn't contribute to heart disease, when what they really mean, or the point that I think is trying to be made originally, which gets broken down through the game of telephone and social media, is there are other risk factors that might be more important, and we should also focus on the things you mentioned: visceral fat, metabolic syndrome, lipoprotein insulin resistance score. And there tends to be an over-focus on LDL-C as an isolated variable, which is, all things being equal, a weak contributor compared to these other things. But that doesn't mean if you have an LDL of 400, you're not at increased risk.
Yeah.
So,
Super interesting. And you mentioned ApoB, and that's not a standard marker that we have on a lipid panel here in New Zealand, though from memory, and it has been a while, you can get it for anyone interested. We do have companies like NutriSearch in New Zealand, Nutripath in Australia, whereby you can get a cardiovascular disease risk profile that incorporates different subfractions, and I believe lipid pattern. I can't recall whether they do ApoB or not.
ApoB, just for, I probably should have said this earlier, but basically LDL stands for low density lipoprotein. It's a particle. That particle contains cholesterol. The amount of cholesterol in your LDL is the LDL cholesterol. What ApoB is it's a protein that's part of the particle. So every LDL particle has one ApoB lipoprotein. And there's a broader family of like LDL particles and its cousins that also have ApoB, things like Lp(a), VLDL. But most ApoB contribution comes from LDL. And so ApoB is kind of a proxy for the number of LDL particles that are floating around. And LDL particle number is actually a better risk factor than total LDL cholesterol, because you can have more large, fluffy particles, and if you have large particles, you'll have fewer particles for the same amount of cholesterol. You know what I mean? And that tends to be a healthier pattern. All things being equal, you want more big, fluffy LDL, less small, dense LDL. That's what a healthy pattern looks like. Tend to be called pattern A versus pattern B.
And as I understand it, for people getting just a standard lipid panel, which might just show you total cholesterol, HDL, triglycerides, and then also give you a calculated LDL number, is it that the triglyceride and HDL ratio are a proxy for the size?
Yes, in a sense. So, yeah, a pattern A, good pattern, has lots of big fluffy. Pattern B, bad pattern, has lots of small dense. And if you have a very low triglyceride to HDL ratio, it's very, very high probability that you have a good pattern, a pattern A, big fluffy. So you don't necessarily, like if your doctor's not going to order an advanced lipid panel, you can just try to see if you can get your triglycerides low and HDL high, and that will inform the quality that's behind whatever the LDL number is.
Yeah.
So you can derive a lot from just the triglyceride to HDL ratio. So, for people looking at the standard lipid panel, that's kind of what I suggest focusing on. And if we want to give people kind of goal numbers, HDL, so the cutoffs for metabolic syndrome, for men, it's 1.03 millimoles, 40 milligrams per deciliter. I think that, a healthier number to shoot, and then for women, it's 50 milligrams per deciliter, which is 1.293 millimoles. I think, in general, levels above 60 milligrams per deciliter, so like a 1.5 millimole HDL is pretty good. Aim for like a 1.55 is kind of decent. And then for triglycerides, ideally levels below 100 milligrams per deciliter. So below 1.13. What we're seeing in lean mass hyperresponders, just to kind of give you a sense, because these are a pretty extreme profile, the averages in our study were HDL of 2.56 millimole, so 99 for HDL, and triglycerides of 47 milligrams per deciliter, so 0.53. So you can see the triglyceride to HDL ratio is shockingly low. But in general, I think, lower triglyceride to HDL ratio, you should probably feel pretty good. And if you can get a lipoprotein insulin resistance score, that's awesome. Other than that, it can be simple things like just check your waist circumference. If your waist circumference is going down, it's probably good for your heart. Yeah. And then, your LDL level, your doctor might fixate on it. I think, within a range, depending on your pre-existing conditions, like, a level of 150, which some people are like, this is shockingly high. That if you have I'm not even going to comment. You could probably guess what my opinion is. I'm not in a position where it's ethical for me to for me to comment I shouldn't. You should have a
Yeah,
conversation.
no, completely. So a couple of things. One, I mentioned psyllium husk as a potential. So you have a teaspoon of psyllium husk in a large glass of water before each meal. That actually has been found, I believe, quite reliably, both clinically and also there are studies to lower LDL. So anyone who
Yep.
has any sort of concern, like that's quite a good option to my mind.
Mm-hmm.
And then with regards to the increasing HDL, obviously exercise can boost HDL. Incorporating more fat into your diet can increase HDL. Any magic bullets there, Nick, outside of those two things?
First of all, for the LDL, I would say soluble fibers, so psyllium husk, or just eating more fiber, chia seeds, flax seeds, and more, especially polyunsaturated fats, which I'm not recommending seed oils, but you have some unroasted, unsalted nuts. I actually think sesame is pretty cool. Tahini, it's great. That'll probably lower the LDL. The HDL, here's the thing with the HDL. I wouldn't HDL chase.
Yeah,
if you
okay.
improve your metabolic health, you should get to a healthy HDL level. And HDL cholesterol levels, it's a metabolic marker, but it's noisy between people. My HDL of 90 might be functionally equivalent to someone else's HDL of 70. Finding these hacks doesn't tell you that much about HDL functionality. In fact, if you want to get really complicated, in population studies, HDL above 80 looks bad. I think it's different in lean mass hyperresponders because, again, it has to do with genetics versus metabolic response. But I wouldn't HDL chase. I just don't think that it's telling you much about flux. I think that having a bad HDL to triglyceride ratio or triglyceride to HDL ratio where you have very low triglycerides is probably indicative in most people of metabolic dysfunction.
Yeah.
But it doesn't mean that you get healthy and I'm going to be healthier if I bump my HDL from 60 to 70. If it happens organically, then fine. But I wouldn't, try to supplement. I mean, a lot of the drugs that we used to think boosting HDL will be good. So you develop drugs for it and turns out, guess what? They don't work. So it's an imperfect marker. I would say if you have a bad triglyceride to HDL ratio, then you should work on improving your metabolic health. But don't focus on just boosting your HDL to balance out with your LDL.
Can I ask you, Nick, do they have a potential idea on why high HDL is considered a risk?
Yeah, it's thought that high HDL reflects poor HDL functionality. And there can be lots of reasons for that. So, think about it like this. For example, you could have a mutation in this, this protein SCARB1, which is important for HDL uptake, right? And so one of the good things HDL does, it traffics cholesterol around. It's involved in reverse cholesterol transport, right? Taking cholesterol out of tissues, bringing it back to the liver. Now, what if I told you I'm going to block the liver's ability to uptake HDL? What happens? HDL goes up. It breaks the functionality, right? Yeah. And so if you have, a population you're studying and that is a genetic factor driving an increase in HDL to very high levels, well, yeah, it's not surprising. You're breaking the functionality. That's why you're getting the high levels. So it's not, the HDL level's not necessarily telling you about the flux. And there's some thought that the high levels themselves can decrease functionality. I'm not really convinced by that. That's done in some in vitro data. But I think that the takeaway is at these very high levels, there are genetic manipulations that are causing it that are kind of associated with either other increased risk factors or a dysfunction in HDL metabolism, HDL's ability to do its job, which results in high HDL levels.
Okay.
So that's kind of the way to simplify it. Again, it's the downside of looking at associations because it leads to a nutritional epidemiology or lipidology epidemiology.
Yeah, no, it makes sense.
False conclusions about what is good or what is bad. These are markers that you should take in a particular context. And I will always maintain that it's important to look at combination lipid profiles. So an LDL of 250 in the context of triglycerides of 1,000 is very different than 250. I think in triglycerides of a lean mass hyperresponder, I would guess. and then genetics versus metabolic adaptations.
Yeah,
And you can draw whatever analogies you want. I mean, it'd be like, is a glucose of 200 or 150 bad? Let's say 150. Well, if it's your fasting glucose, yeah. But if you're doing, a sprint workout, then no. It's context.
Totally.
So,
Nick,
yeah.
So finally, a final question. Like you mentioned leptin's role in the response that then leads to these sort of skyrocketing LDL levels.
Mm-hmm.
So for those people who have metabolic conditions or conditions that don't allow for additional carbohydrate, what about just giving them a shot of leptin?
For what purpose? If they don't allow for... Oh, I see what you're saying. So if you take a lean mass hyperresponder and you shoot them up with leptin.
Yeah.
I know. I'd love to do that experiment.
Yeah, it would be interesting.
I'd love to do that experiment. I mean, that's again, one of the things that, like, it's just about what you can do ethically. The funny thing is, I pre-MD, I don't have access to some of these things myself. Like, I would love to just get, like, all the LDL lowering drugs, shots of insulin, shots of leptin, and do, like, crossover trials on myself for hypothesis generation.
Yeah.
But I can't because people just won't give me, like, a boatload of PCSK9 and insulin and leptin. So that question is a great question that I'd love to investigate. Unfortunately, I can't do it yet.
Yeah, no, it's interesting. There was some leptin research being done in University of Otago looking at, it was just a mice study. And in fact, the whole entire context was entirely different. But I was thinking about it from a, thinking, well, I wonder at what point that will then get into a clinical trial for, I think they were looking at functional amenorrhea. So clearly a very different sort of population. Well, actually, I say that though, not necessarily.
I haven't had a period in a long time.
Yeah, well, there you go. Yeah. That was just something that I sort of came to mind. Nick, actually, that wasn't my last question. My last question is, what pushback are you getting? I mean, obviously a lot of favorable responses, which is always awesome. Any pushback from people who are really sort of been ensconced in this cholesterol, area for, forever? Like,
I'm going to say this, and I don't mean to be dismissive, but not anything that I consider very serious. And
okay.
and that's going to, if certain people are going to find that disrespectful because there has been pushback on social media, but
different.
It's not been really attacking what I consider the science. It's been attacking what I consider to be misperceptions about conclusions that I, for one, am not drawing about risk, or about things that are just kind of like not that important, like nomenclature. So people attacking, you shouldn't call them lean mass hyperresponders because you don't have adiposity data on the original cohort. I'm like, fine, we'll rename them. Like I'm not. They like literally said in a letter to the editor, you should call them like normal BMI hyperresponders, and I'm like, it's a historic term. If we want it, I don't care. Let's rename it. And it's actually ironic because like there's a lot of terms in medicine that just don't fit up well. PCOS, polycystic ovarian syndrome.
Oh,
do you need
tell me about it.
Ovarian cysts to have polycystic ovarian syndrome? Nope. No. Yeah. Like there's a lot of things that are like that. It's just the way historic naming goes, and I didn't name it. Let's rename it. But like that kind of pushback, or people saying that like, we shouldn't be studying this because we know they're at increased risk and it's unethical to do so. I'm like, people are refusing care. This is an interesting phenomenon. Scientifically, we should study it. This is a worthwhile question to ask. So we haven't had any pushback, let me say, on the scientific principles of the model, which we only, granted, formally put out in peer review recently, so there hasn't been that much time. But I haven't gotten any email saying, you're wrong here. You screwed up the science, like the metabolic justification isn't there. And we've had a lot of, we've passed it around prior to publication and only received positive feedback. And outside of social media, this is what I find so encouraging. I've gotten a lot of positive solicitations of people saying, this is really interesting. So like people that aren't acquainted with the controversy pre-existing, even before me, in social media, have generally just been really fascinated by this. And those are the people that I take seriously within academia, not some rando who's trolling me about things that I never said that I'm getting misquoted on, which happens. So you can't take it too seriously. But it's been a really engaging discussion. And I will say that the people that push back on the risk thing, I do understand where they're coming from. Because from their perspective, especially the physicians, I'm sure they see a lot of people like the person you talked about earlier, where they're like, they're their patient, but then they're getting the narrative of LDL doesn't matter. So then they're worried about their patient because their LDL is 500 milligrams per deciliter. And they might not be a person who's even a lean mass hyperresponder. They could have FH, and the whole narrative just gets screwed up. And then they're worried about the patient and think that I or Dave am saying something we're not. So it gets a little bit hairy. But I'll leave it at that, and also just say that I am someone who is always willing to get on the phone and talk to anybody who has issues about this. So if you're someone who's genuinely interested, I'm known for being willing. If you're a physician listening and you're scared for a patient and you want to get on the phone with me, reach out to me on Twitter or somewhere elsewhere, and we can have a conversation on the phone. That's not in 180 characters. Or something, because I think this is important, and my number one rule is don't put people in harm's way unnecessarily.
Yeah, no, that's awesome, Nick. And certainly across our conversation, you haven't been wedded to any idea that it doesn't matter or, the risk is low or anything like that. You're clearly quite open-minded and about what we know, what we don't know, and being conservative. And I think, people will appreciate that. So thanks for your time, Nick. You've been amazing. And I think I would love to chat to you at another time about your other research, your PhD, mental health stuff. So I might hit you up there because gosh, you're only training to be a doctor. Surely you've got plenty of time up your sleeve.
We're about to have a 2-week break, actually. That's our summer break. Our entire summer break is now 2 weeks. So that's lovely after our final exam for nephrology, endocrinology, and GI this coming Friday.
Amazing. Well, good luck with that.
It's fun stuff.
It sounds fun. And what I will do is I will put links to both papers that we were discussing today in the show notes, in addition to Twitter contacts for you and Dave with regards to that study that you mentioned. And then that is also a good opportunity for people to reach out if they've got questions. So
absolutely.
Amazing. Thanks so much, Nick.
Thank you so much, Mikki.
Alrighty then, hopefully you enjoyed the conversation that I had with Nick. You can see he is such a smart guy, and I'm really looking forward actually to having him back on for us to talk about his PhD work in the neurodegenerative space, because that's something which I'm super interested in. Next week though on the podcast, I have the pleasure of talking to Beth McLean, who is a PhD student over in Perth, studying the intricacies of iron metabolism. Until next time though, you can catch me over on Facebook at Mikki Williden Nutrition, on Instagram and Twitter at Mikki Williden, or over on my website mikkiwilliden.com, where you can book a consultation, sign up to a number of my meal plans, be it fat loss, ketogenic, longevity approach, a real food nutrition plan, or even just access to my recipe portal, where for $12 a month you get a recipe library of over 900 recipes, which is regularly updated, access to our private Facebook group, my weekly emails, and you get access to me to be able to pick my brain on anything nutrition related. Alright team, you have a great week and catch you soon. See you later.